so I'm recording. So the exam will be on Thursday, on the 22nd, and the material for the exam, I recommend you read tests 1 up to 4. And I also supplied all the answers for each test on Blackboard, where the tests and exam folder. You can open those, and then there are answers there. I think you have enough resources, and you have also this practice test and their answers, and you have your notes. So you have a lot of material. I would just generally pick a few questions of each. What I tell you what I tell you now is chapter 20 will not be on the exam. I would say that chapter 20 won't be on the exam. Okay, chapter 20 means solve the trig function, prove this, prove that. That is pre-calculus. Technically, because you didn't do it in the previous years in our St. Clair College, then we had to include that. But you were supposed to do that before you take calculus. So this is a differential calculus course. On my exam, I will not include chapter 20 that way. This is test 3. Partial test 3 was like chapter 20, and one question maybe on test 4. Okay, is that clear? Am I clear with that? Yes. So chapter 20, which is the trigonometric identities and proofs and solving trigonometric equations, will not be on the test, on the exam. I mean, won't be on the exam because it's pre-calculus material. The course focuses on calculus, and then the chapters are chapters covered on the exam are, I could say, 23, 24, 27. Chapter 23 is differentiation. Chapter 24 is application of differentiation. Chapter 26 is trigonometric differentiation, and of course differentiation of transcendental functions, trigonometric being the major one, and we will do logarithms, we will do exponentials. Okay, let's go directly to the section 27.5, where we have to find the derivative of the logarithms function. Trevor, is that okay? Okay. All right. So I will do so this is week 12. 12 times 2 is 24. So this is lecture 23. Well, this is Thursday, 24 then. Section. I will adjust those names later on. So section 27.5. Derivatives of the logarithmic function. I'm gonna share this with you. Okay. So this section will deal. So hopefully everybody sees my OneNote. Thank you. Thank you so much. So if you do the definition, like the limit of f of x plus h minus f of x over h. It approaches to infinity for y equal to logarithm of log of u to the base b, then dy by dx would be simply 1 over u log of e to the base b du by dx. If you apply this, you will get this. For if f is log of u to the base b, the answer for this would be 1 over u log of e to the base b du. The book has done it, but I don't have time, so I will take directly the result, so I can use that. So I can use the techniques. We can learn the techniques. So this is one formula. You know that you just have to really see what it is. Say for example, simple example, if they give you y is equal to log of x to the base 2, what is the derivative? Is of course 1 over x. So 1 over u, 1 over x. This is the domain part. This is the base. This is the domain part, right? The input. So 1 over x log of e to the base 2 du by dx, which is 1. The derivative of x is 1. So that's the answer. So for example, but another example is if I say a here, b, so log of say sine x to the base 4. What is the derivative? This would be 1 over, if this is that, dy by dx would be, remember, this is your domain, this is your input. What does the logarithm derivative do? It does what? 1 over the input, 1 over the input times the derivative of the input. Oh, first, because this is logarithm, times log of e to the base times the derivative of the input, which is cos of x. So this would be cotangent of x log of e to the base 4, because cos over sine is cotangent. Do you understand? Yeah, so therefore this is the we don't use it a lot. We use LAN. LAN is called, as you know, natural logarithm. You know, note. Okay. Yes. Yes. Thank you. Yes. So log of x, the base e equal to ln of x, ln of x, and then that's it. Mathematicians don't want to write log of x, the base e, all the time. Whenever when the base is e, they want to avoid and save time by saying ln of x. But technically, e, you know, is approximately equal to 2.72. It's an irrational number. You could get e to the 1 on your calculator and you get the number. So that number is important in mathematics. If you have a logarithm to that base, most of the function is going to be ln. Now I want to have a second formula. This is the first formula where the base is b. But if it's particularly base is e, then it's called ln. It's the same. It's a logarithmic function. Don't be confused. But the ln function, as you can see, what is the formula for the log? We said log's derivative of u, the derivative of log u to the base b is, we said 1 over u log of e to the base u, right? E to the base b, sorry, du by dx, we said. If you replace log of u to ln of u, what do you go? If you do that, 1 over u, the only difference between the two is that the base is b on the first, the one on the ln has base e, so it is 1 over u, the same, log of e to the base e, because b would be replaced by e, du by dx. So in that case, that means this, but we know log of e to the base e is equal to 1. You know, logarithm of a number to the base, the same number, is always 1. So therefore, it becomes an easier version, 1 over u du by dx. So the logarithm of ln is much easier. So ln of u derivative is 1 over u du by dx. Therefore, d by dx of ln of u would be the second formula, 1 over u du by dx. To tell you the truth, this is the most important in this section, not this one. This one, because this one has this number in there. This number is, you know, a number. For example, what is log of e to the base 4? You can find out. That's a number. That's the number. It's just an irrational number. So therefore, you could always find it on your calculator. So that number will be eliminated if we are dealing with ln x, because the base becomes e. Log of e to the e is 1. So it won't appear on the final result. So that's why we have a clean and nicer version of the derivative of the logarithm in such a way. Okay. So I will do some examples from textbook. On page 851, section 27.5. Okay, let's say number 4. The instruction to find the derivatives and simplify. Find the derivatives and simplify. In other words, I'm saying give the answers in simplified version. Number 4, it is y equal to logarithm of 9x to the base 2, right? So therefore, dy by dx is, what is it? Can you help me? One over 9x. Very good. That's a start. 1 over 9x. Because it's log.
Sorry,
Go ahead.
No, you're good. You can say it.
Oh, I'm a very lucky man. Very nice. Respect to each other. I appreciate it. Go ahead, please.
Log 2 to the power of e.
Log of, yeah, log of 2 the base e. Is that it or not yet?
I think e should be at the upper side,
yeah,
right?
e the base 2.
Yeah, 2 exponent e.
The formula says
And then
it's the base 2.
and then the derivative of the 9x, right? Will be
Which is 9. Yes, definitely. Thank you. All right. So this 9, the derivative of 9 can come. Thank you, Wissam. Up front, you can cross this 9 by 9. Then you'll have log of e base 2 over 9 is an answer. I think we don't see much in a lot of application. Most of the applications are the base e, but that's exactly what it is. I don't use this formula. I always confuse me e to base b or b to base e, but I think the e must be the input. Okay. Dima denominator. Yeah, it's probably I missed the x. Yeah, not x. Thank you. Appreciate it. All right, let's do number 6. One more of the logarithm. So y equal to logarithm of x squared plus 1 to the base 7. That's how I read it. The base 7 is not something you change. It's part of the function. Okay. So dy by dx again is could you was it Dima you were about to say? Could you answer that if you want, or whoever was trying to answer, if you don't mind, or I could do it myself. Either way.
Could I give the answer?
Yeah, go ahead.
Wouldn't it be 1 over x squared plus 2 log to the base 7e plus 2x
Log of e to the
times
base
2x,
7.
sorry.
Thank you. Perfect. You're right. Just I want to make sure that the 2x must be in brackets. Thank you so much. That's perfect. So then I can bring out that 2x up front, not to confuse to multiply with e. We can't multiply that because this is 1. Okay, so 2x over x squared plus 1 log of e to the base 7 is the answer. Okay, this is a number, by the way. Who can help me to find that number? What is log of e to the base 7? You can change it into, you can take log of e to the base e over log of e to the base, log of 7 to the base e. These are the same, if you remember logarithms property. So log of e to the base e is 1. Log of 7 to the base e is ln 7, which is equal to 1.945910149. And I flip that, it's actually 0.513898. So that's the number. You can say it's very hard because we are really approximating it. 0.513898 time 2x over x squared plus 1. We can even multiply by 2. It would be 1.027796685x over x squared plus 1. If someone does this, I can't complain because that's the exact value of that. But actually, I prefer to leave it like that, unless you want a number for your measurement. Then you have to change that into that. This is a number. E is a number. The base is a number. You should come up with a number. If you don't remember this, the property of the logarithm which I applied is log of x to the base b is log of x to the base c over log of b to the base c. This is one of the famous properties. But nowadays, really, this is the way I was taught in the old days, because there was no calculator which could do any base. That's why we have the log button on our calculator and the ln button. The log button is log of x to the base b. Log x means log of x to the base 10. Ln means log of x to the base e. There were only 2 buttons on our calculator which that can do the logarithm. One is base 10, which is they don't put the 10, knowing that people have agreed not to write the base 10. It's called common logarithm. You don't write base 10. If it's ln, it's base e. Okay, so but I am sure nowadays they have a button like that, log of. Your calculators might have that. If that is the case, then you can fill these 2 numbers in immediately without doing this property. You will get a number. Okay, I shouldn't spend so much time on that one. Okay, so we'll go the ln number 8. The ln function is much easier to find the derivative because that number is not going to be part of it. That number is 1 all the time. So 3x squared minus 1. Okay, dy by dx, just to save time, I'm going to go forward. So 2 over this, the input, times the derivative of the input. That's what the derivative of ln of u is. Derivative of ln of u is 1 over u du by dx. That's all. That's what I'm applying here. 1 over u, 2 over u, because the 2 is a multiplier, times the derivative of u, which is 6x. So this is 12x over 3x squared minus 1 is the answer for it. Number 12, if we have y equal to ln of 4x minus 3 cubed, dy by dx would be simply, there are 2 ways to do this, but dy by dx is 1 over the input according to the rule, right? This is my rule. 1 over u, 1 over 4x minus 3 cubed times the derivative of u. The derivative of u is a power rule. Bring the 3 up front. Write the base. Subtract the exponent by 1 times the derivative of the inside. Okay, that's complete now. So therefore, this is 4 times 3 is 12. This to the power of 2, this to the power of 3 will be just 4x minus 3. The top one has 2, the bottom one has 3 powers, then one power is left on the bottom. So that is the answer. Okay, the other way to do this is you can even another way to do this, which is not, you don't have to be bothered by it. The same function y is 3 ln of 4x minus 3, isn't it? What do you remember the logarithmic property? Another property of the power. If you have, yes, maybe an answer I got. Yes, that remember, log of x to the n, the base b is n log of x to the base b. See, you can bring the n up front. So therefore, I'm bringing the 3 up front. I am not even finding the derivative yet. That is before I find. That's the property of logarithms. Then dy by dx would be simply 3 times the derivative of that. The derivative of that is 1 over the input times the derivative of the input, which is 4. Which is 3 times 4 is 12 over 4x minus 3. The same result we get. You know, if you don't want to do the property of the logarithm at the beginning and then do the derivative, you can do directly the way we did it the first time. I don't know. Okay. Okay. We will do the more questions. Is there noise in my part, like in my side? Did you hear, or are you okay? I'll change rooms if that's the case. Okay, thank you. I'm good. Yeah. So number 16 is product rule. Y equal to 6x squared ln of 5x. So there are two functions. One of them is u, the other one is v. One of them is u, the other one is v. Then, you know, uv is u prime v plus uv prime. Right? So the derivative of dy by dx is the derivative of u, which is 12x, times v plus u times the derivative of v, which is 1 over 5x times the derivative of 5, the derivative of 5x. So this is 12x ln of 5x plus 5's cancel. I got 6x squared over x, 6x squared over x. You could have done that too. You didn't have any other. I think we could do that. 6x squared divided by x is 6x. You can factor, but you can leave it the way it is. You can factor 6x if you wish, or 6x is factored, so 2 is left plus 1. Both I will mark right. Now let's continue on question number sorry. All right. 16 and 18 is some quotient rule. 18, they gave you y equal to 8 ln x. As I predicted, there is a lot of ln x quotients than log x because they are more applied in engineering. So what is dy by dx? This is the same as finding u over v prime. So u prime v minus uv prime over v squared. So I'm going to find the derivative of the top, which is 8 times 1 over x. The derivative of ln x. Derivative of ln x is simply 1 over x, 1 over the input. The derivative of the inside is just 1. So that is the derivative of the top times the bottom minus the top times the derivative of the bottom, which is 1, over the denominator square. So this is x cross x, 8 minus 8 ln x over x squared. Or we can leave it like that, or 8, 1 minus ln x over x squared would be the answer. Both are good answers. Number 20, I have y equal to ln of 2x over 1 plus x. So this is chain rule. Again, chain rule, dy by dx is 1 over the input, 1 over this. You shouldn't have written this because I'm writing it to make sure you follow me, but normally you can flip this. Obviously, 1 over a fraction, a over b is b over a, right? So you can immediately flip it, times the derivative of that, which is quotient rule. Quotient rule, the derivative of the top is 2 times the denominator, minus the top times the derivative of the denominator is 1 over 1 plus x the whole squared. Okay, so this is 1 plus x over 2x. We flip that times, what is this fraction? 2 plus 2x minus 2x over 1 plus x the whole squared. So this is 1 plus x over 2x, and in here 2x cancel. It is 2 over 1 plus x the whole squared. So I think the 2's cross out with the 2, and this linear factor will cross out with linear factor. So I guess 1 over 1 over x into 1 plus x is what we have. Okay, I will eliminate these cancellations and show you again. Right? The 2 crosses out the 2 in the denominator. The 1 plus x factor will take away 1 plus x factor from the denominator. Will be left with 1 plus x factor on the denominator. I'm okay. Let me know if there is an error you think. Yeah. You can leave it like that, or you can put like that. One more maybe. One more, number 22. Is it time? Yeah. Arthur, can you do that? With the Arthur, okay, I can do it. Is it ln of 1 plus x in bracket or 1 plus x in bracket? Oh, are you answering the question that I just did, number 20, Arthur? No, number 20 has no ln as an answer. Oh, yeah. Originally the question, very good. You see, smart. So I think, what is number 20? It is ln of y equal to ln of 2x over 1 plus x, right? By property of logarithms, before you find the derivative, you could do this as ln of 2x minus ln of 1 plus x. Now the derivative of dy by dx could be ln of 2x is 1 over 2x. Ln of 1 over x is 1 over 1 plus x. 1 plus x. Okay, if you join this together, I'm sure you should get the same answer. Okay, so what is it? So you have 1 plus x minus 2x over 2x into 1 plus x. So what we get? So 1. So did I mess up somehow? Yeah, there was a 2. Yeah, I forgot. The derivative of the derivative inside is 2, so it's 2 over x. Sorry. So the 2's cancel. So I have 1 over x minus 1 over 1 plus x. So what we get is 1 plus x minus x over x into 1 plus x. This is how you add how you subtract them. So this is 1 over x into 1 plus x. Yes, you're right. That's an alternative way. Before you do the derivatives, you just do the property of a logarithm of log of a over b is log of a minus log of b. This is also very good, Arthur. I like that. That's also an alternative. Number 22, quickly, let's do that, and then we finish. Ln of x root of x plus 1. Okay. The derivative, I don't think that's an easy one. Okay, I will do it number 22 here. Y equal to ln of x root of x plus 1. Okay, the derivative of dy by dx is, you can make this also ln of x plus ln of root of x plus 1 as Arthur, but I'm not gonna, I would rather do it immediately with the way I get it. So ln dy by dx is 1 over x root of x plus 1. That is the part where it says 1 over the input. Whatever input you have, 1 over of. If it's ln, it's 1 over that times the derivative of that product rule. The derivative of that is 1 times root of x plus 1 plus x times the derivative of root of x plus 1 is 1/2 x plus 1 to the minus half, isn't it? So this is equal to 1 over x root of x plus 1. And in here, I got root of x plus 1. And the derivative here would be x over 2 root of x plus 1. This x is in the denominator. The negative half goes to the denominator to become a square root. And there was a 2 already. So, you know, a plus b over c is simply ac plus b over c. So I have 1 over x root of x plus 1. I have to fix this adjustment first. And then you have 2 times x plus 1 plus x over 2 root of x plus 1. That is exactly applied here. This times this, which is 2 times root of x plus 1. Root of x plus 1 is just x plus 1. Times this times this, which is x, divided by the product of these two, which is that. So that's how I got that. Then I will simplify 1 over x root of x plus 1. Okay, and in this one, 2x plus 2 plus x is 3x plus 2 over 2 root of x plus 1. All right, because this is 2x plus 2, right? When you add it with x, it becomes 3x plus 2. And then this is simply 3x plus 2 over x, 2x survived there. Root x plus 1 is just x plus 1. You can leave it like that, or 3x plus 2 over 2x squared plus 2x would be the answer, or you can factor the 2 out. I don't know. Does the last question make sense? Did you follow me? That's probably the hardest question we did. Okay. Yes, Arthur, thank you. Is it okay? If it's okay, then I think it's we passed even the time, so I think we stop here. I will post these notes. You should get. I will also assign homework. You can. We did up to. Okay. You can. I can write it right away. Please try practice on section 27.5 numbers from 3 up to, we did up to 22, but there are interesting questions up to 30, so you could do up to 29, I guess, up to 20 now, up to 31. to 29 is good enough. We didn't do much. Yeah, okay. Odd. These are homework. Like when I say practice, it means homework. This is page 851. And then we're going to do next class. I will do section 27.6, exponential functions. It's a very, very easy section. Like we're going to do e to the x, the derivative of it is e to the x. So easy. There is also e to the u, which we're going to do. So those this section will be done in 20 or 25 minutes next class. After that, I will start to do the tests from test 1, test 2, and so on. Okay. Thank you so much for today. Appreciate it. Thank you, sir. Thank you. Thank you. Sorry to keep you late. Thank you, Michael. Rafael, have a great day. Thank you. Catherine, thank you. Have a great day. Jesus, take care, my friend. Thank you, sir. Bye, Arthur. Thank you.
Hi, sir.
Bye. Is that Dima?
Yeah, sir. I submit the test on 11 and 18.
Okay, hold on. I'm gonna